In this video, we are going to look at a couple of examples where Newton's laws are applied. Hi, this is Sean Huang from the physics department. If you have not watched the videos on Newton's laws and types of forces, you can find the links down below in the description. Before we get started, you will want to recall that in all examples involving Newton's laws, we have only one tool, and that is F equals to ma. In addition, you want to know that Newton's first law is a special case where A is equal to 0. And Newton's second law is just the equation itself. And Newton's third law says that F cannot come from m, it must come from somewhere else. One last thing, the equation should be read from the right to the left. You must first determine what m is, what motion it has, and then conclude that there must be a net force that matches the product of m and a. In problem 46, the m is the helicopter, which is doing a constant velocity motion, which means that the acceleration a is 0. There are three forces acting on m: the lift L created by the blades, the gravitational force W created by the earth, and the resistance R created by air friction. So the left-hand side is a vector sum and the right-hand side is 0. The problem now becomes a vector addition problem. If you'd like, you can review the videos on vectors and vector addition, the link of which can be found down below in the description. For L, you want to draw an auxiliary line that makes a right angle with the x-axis. Then you can see the right triangle, its hypotenuse, the side which is adjacent to the angle theta, and the side that is opposite to the angle theta, just like what we did in the first vector video. Notice that since the angle specified in the diagram is 21 degrees, the angle theta is 69. We now have all the information we need to write down the component form for L. The other two vectors are more straightforward. After completing the vector addition, we can see that we now have two simultaneous equations, the second of which will give you the answer for part A, and the first will give you the answer for part B. Do them in that sequence. In problem 59, we again have a helicopter, but this time the M is the L-bone part, so you actually want to ignore the helicopter and focus on the pod. The pod is moving with an acceleration of a, which is possible if and only if there is a net force F acting on the pod. This net force must be the sum of the tension T in the cable and the gravitational force W created by the Earth. So again, we have a vector addition problem. After completing the vector addition, we again have two simultaneous equations, from which we can solve for the Tx and Ty. The magnitude and direction of the tension T can be found using the Pythagorean theorem and the arctangent function respectively. In problem 60, the m is the skier. In part A, she sped up to a speed of 11 meters per second in 8 seconds. So m exhibits an acceleration of 11 over 8. And there must be a net force acting on m with magnitude of m times a. And that is Newton's laws in a nutshell. In part B, we do the same. Notice that since the problem asks for the magnitude only, the answer is 38.24 without the negative sign. In problem 61, we have a rescue situation where a man is being lifted from a boat. In part A, they are asking what tension will be needed if the man has an upward acceleration of 1.1 meters per second squared. This is a 1D problem, and we can do our reasoning in the head. Here, the m is the man being lifted, his acceleration being 1.1, which is possible only if the tension T is big enough to overcome the gravitational force W and still have some heft left going up. So T minus mg will be equal to ma. In part B, the man is moving at a constant speed, which means the acceleration is 0. Applying the same equation again, and you can easily see that t is equal to mg. In problem 62, the m is the boat on the trailer. So you want to focus on the boat and trailer and forget about the car. The m is being accelerated with a value of 11/28, which again is possible if and only if the tension T matches the product of m and a. In each of the problems in this video, we will start by identifying the m and its motion. Sometimes the acceleration is 0, sometimes it is not. In all cases, we have F equals to ma, and that F will always come from a source other than m. In the videos that are yet to come, we will see more advanced examples, but the principle that we used in this video will remain the same.